Because there are so many choices when you're building a UniFi network, it can seem a bit daunting at first. Which wireless access points should you use? Which switches? How should you run your controller? There are many decisions to be made. So what I'd like to do now is talk about a couple of typical use cases, go through some factors that can influence particularly the access points you choose, and then also leave you with a good resource for doing some capacity planning. Let's start with one of those scenarios. And I want to start with a really simple one. A one-bedroom flat. Now, think about what this means. You're going to have a small number of people, probably 2 at most. You've got a very small distance to cover. And inevitably, there's not going to be many devices that need connectivity. This is about the simplest scenario you could possibly think of. And in fact, at least in the home, it may even be overkill for a UniFi network. Having said that, a small one-bedroom flat is often a stepping stone, and you may want to take that UniFi network and then build it out when you move into a larger house, for example, if you have a family. Either way, let's talk about typical components. Now, I'm going to start with something easy, and that's the controller by virtue of a cloud key. This just makes it easy. And again, it is a dedicated unit built specifically by Ubiquiti for running the UniFi controller. It's a very small space, so an AP/AC light will be more than sufficient to provide Wi-Fi. And the same could be said if this was a rollout in, say, a small cafe. If you've only got capacity for 20 or 30 people, and some subset of those are going to be using Wi-Fi over a pretty constrained space, an AC light would be just fine. I'm going to add a security gateway, and to tie it all together, a switch 8. Now remember, the switch 8 only has one PoE out port, so you could plug, say, the cloud key into that. Now that means your AC light won't be getting power from the switch, but the AC light ships with a PoE injector, so you can always use that to provide power to the unit, thus allowing you to have the smallest possible switch. If you really wanted to power that AC light off a switch, and perhaps you also want to do a bit of future-proofing in case you add other PoE devices later on, you might use one of those switch 8 60 watts, and then you'd have 4 PoE ports. And these are the sorts of decisions you need to be making when you design your network. But I wanted to try and show the smallest possible use case. And that's precisely what you see here, and that would still give you a very good network indeed. Let's go further though, and let's expand out into a house. Now this could be a house, or it could be a larger commercial environment. The main thing is that we're talking about more people, more devices, and very importantly, more distance over which we need to provide connectivity. Now in a scenario like this, you might start to look at something like AC in-wall units. In the previous scenario, none of the components I chose require any hard mounting in the environment. So for example, if you were just renting a flat, you could sit everything there on a desk somewhere. In this scenario here, where you might own your own house, installing the in-wall units would actually require drilling into walls. These do get mounted in the plasterboard. That is a fantastic option if you have the capability to do that. Now, if you didn't, or if, like my house, it's already wired for Ethernet and it has just traditional jacks mounted on the wall, you may instead use AC pros. And in a larger house, you may choose to have several of them. You could always use the AC lights from the previous scenario, but they're a less powerful unit. You can get a higher throughput on the AC pros. And one of the decisions you need to make is whether or not that's important to you. Those AC lights run at 867 megabits on 5G, whereas the AC Pro runs at 1300. So that's a fairly big difference in terms of speed. But again, it'll depend on your use case, because if you're predominantly just going out over a limited internet connection anyway, and you don't have a large number of people using the one access point, it may not make much of a difference. I'm going to add a cloud key again to this scenario for all the reasons I explained earlier. And a normal security gateway rather than a Pro is still just fine in this scenario. Now, because we're going to have multiple PoE-enabled access points here, I'm also going to use a Switch 8 150 watt. So now there's 8 PoE ports here. So that's plenty to run as many access points as we're probably going to need in this scenario, as well as also run the cloud key as well, because remember that's PoE enabled too. A little bit later on, we're going to build out a network that is very similar to this one just here. It's a commercial premise spread over a distance that a typical house would cover, and it's going to use all of the devices you see here and more. We could keep going and going with these scenarios. We could talk about larger commercial rollouts, but all we're really doing is multiplying what we see here. More access points, larger switches, possibly a Security Gateway Pro, maybe Ubiquiti's managed controller service rather than a cloud key. And again, it all comes back to the modularity of designing your network to meet your specific needs. Let's talk about one of the factors that has a really significant impact on how you design your network, and this is about Wi-Fi quality. So when we have an access point, that obviously has a range, and we've covered what those ranges are for different APs within the UniFi product suite. What is constant amongst all of them though, is as distance increases, signal strength decreases. Consequently, the quality of the connection goes down as well. But one of the things you really have to consider when you're placing these access points within an environment is what else is going to degrade that signal quality. So for example, what happens when you have a wall? Well, inevitably that wall is going to cast a shadow that will decrease the signal quality behind it. Now, plasterboard walls, say between 2 rooms in a house, is one thing. A solid brick wall, perhaps between the inside of a house and the outside, is quite another. So if you did require Wi-Fi connectivity in your garden, say for your connected irrigation system, the access point inside the house, perhaps behind a double brick wall, may be insufficient to provide enough connectivity to the outside of the house. So you might be looking at one of those outdoor mesh units. Another important factor here is the number of people that are actually going to use that network. Now, in a residential setting, that's normally a pretty fixed number of people with a pretty fixed number of devices. Certainly, it's predictable. But along with just the numbers themselves, there's the distance that they are from that access point. Because as you start to get further and further out and the signal degrades, so too does the throughput. And you may well find that even when you reach the maximum range of the access point and you have a signal, it may not be enough for the client to actually achieve what it is they were connected for in the first place. So this is a great example of where the modularity of UniFi allows you to say, hey, maybe we need another access point out there. It'll all be part of the same network. You'll get fast roaming across everything. You may even wirelessly uplink to the first access point. But here is a location on the premises which requires more Wi-Fi. You might even choose a smaller Wi-Fi unit. Maybe you only need an AC light out in this location because it's a fairly constrained space. But again, you can choose. It's a modular solution. And over time, you're going to find that those requirements inevitably continue to change. Because whether you're at home or in a commercial environment, over time there'll be more devices that need more connectivity in more places. Lastly, a tool to help you decide how to build out your network is the Capacity Planner from Revolution Wi-Fi. Ubiquiti's sponsored this initiative, and it's a neat tool to help you try and put some scale around what it is you need to build out in your environment. So we've now covered quite a bit. Why UniFi is a great solution, what the UniFi product line is, and of course designing your UniFi network. Let's now move on and actually build out a UniFi network. So this is where we're actually going to create and configure a network. Let's go and have a look at that next.